We're getting ready to begin our factoring sections. So section 4.5 to 4.8, so 4, 5, 4, 6, 4, 7, 4, 8 are all about factoring. And this is the sections that I told you, if you don't learn this, you can't pass this class, you can't pass another math class. Factoring is something you do for the rest of your math life. So 4, 5, 4, 6, 4, 7, 4, 8, huge topics. And we're learning 8 different types of factoring over those 4 sections. And I think that's what makes the test so hard for students, because they're like, wow, there's 8 kinds. How do I know when to do what? So I'm going to try to give you hints. I'm going to give you a good note page right before the test so you can use it to study the night before. But yeah, there's not really anything you can do except practice. Just like everything else, riding a bike, playing football, running cross country, you don't get good unless you practice. So same thing. But yeah, it's pretty intense. So 8 different types of factoring we're going to learn in the next couple days. So we learned the first 2 in this section. We're going to learn how to do a greatest common factor factoring, and we're going to learn factor by grouping, which actually has the GCF, because we call this GCF, done 3 times in it. And that's why we put them together in the same section. So we learn how to do the GCF. Then we learn how to factor by grouping, which uses GCF but has to do it 3 times. So first let's talk about how do we find the greatest common factor. So we have to identify a term that's common to all the terms. It can't just be common to 2 of them. It has to be common to every single term listed. And sometimes it's going to be numbers, sometimes it's going to be numbers and variables, so you have to search both. And then we're going to use the distributive property backwards in order to divide and find out what's left in parentheses. So numbers first, then letters. So we look at 8, 20, 12, and 20. And we want to find a number that goes into all of those. So I usually pick the littlest number and just write its factors. So does 8 go into those? No. Does 4? Yes. So you always start with the biggest, because greatest common factor means they want the largest. So does everybody agree 4 goes into every single one of those numbers, and it's the largest? If you don't pick the largest, you won't get the right answer. Then with exponents, this is when it gets a little tricky. You pick the smallest exponent. Why? Well, I can't take 8 x's out of here if there aren't 8 to take out. But I can take 3 out of here, and 3 out of here, and 3 out of here, and 3 out of here. So then we take the variable, if it's common to all the terms, and we use the smallest exponent. So this is where, how many times have I said 4.1 comes into play? But this is it again. So really what you're doing is you're dividing each one of these terms by 4x cubed, so you can figure out what goes in parentheses. So 8 divided by 4 is 2, 8 minus 3, x to the 5th. So after I factor out the GCF, this is what's left. And then I have minus 5, 6 minus 3, x cubed. So minus 5x cubed. Minus 12 divided by 4 is 3x. And minus 5. And remember how we said anything divided by itself is 1, so this would just be minus 5. So students always go, well, I'm just learning this. Is there like some way I can check it to make sure I'm right? Absolutely. Distribute. Every factoring problem can either be checked by distributing or foiling. Every factoring problem. So anytime you see the word factor, Just like every time you see the word solve, that means it can be checked. So how do I check? I just go down the line and distribute and make sure I get that back. 8, 3 plus 5, x to the 8th. Boom. Negative 20, x to the 6th. There it is. Negative 12, x to the 4th. And negative 20x cubed. And I tell students you can save so many points on the test by just doing that little simple 10-second check. Multiply what you just wrote for your answer, and you should always get back to the original problem. And before you box it or underline it as your answer, you should make sure nothing's common, because once in a while students will take a 2 out here, and then you'll have a 4, a 10, a 6, and a 10. Well, there's still something common, so that means you didn't take enough out. So if you've indeed taken out the largest possible factor, nothing should be common to the terms in parentheses. So those are 2 little things to look out for. Okay, so let's do one more and then you guys can do one. So 19, 11, 13, and 1. All prime numbers. So guess what, folks? There's not a number common besides 1. But that doesn't mean there couldn't be variables common. So y? Yes, I do have a y common. So then I go down the list and look for the smallest exponent on y. This is y to the 3rd. This is y to the 1st. This is y to the 5th. This is y to the 3rd. So y to the 1st. Is there an n common? Nope, no n there, so I can't take an n out. So all that's common to all of those terms is just y. And that's not y to the 3rd, it's y to the 1st. That 3 goes with the n. So now I'm going to divide every term by y to see what goes inside parentheses, because this whole thing is my answer. Factor means turn it into a multiplication problem. That should be something that you write. So your final answer, whenever it says factor, is, so that would be like if you wrote 2 times 3. Those are called the factors of 6, 2 times 3. So when I finish my problem, it should be a multiplication problem if the directions say factor, and you can see on both of these it is. So take 1y away, 3 minus 1 is y squared. Y divided by y, ding! So that leaves me with minus 13n cubed plus 11 y to the 4th into the 7th. So 11 divided by 1, 11. 5 minus 1 is 4, and then into the 7th. And then minus 19. 3 minus 1 is y squared. And then we have the n cubed. And that's called factoring out a greatest common factor, whatever's common to all the terms. So go ahead and try the next one. That one's yours. So turn off your video, turn it back on when you're done, and we can check it together. Okay, so I look here, and remember, take the smallest one and just write its factors. 1 goes into it, 2 does, 3 does, 4 does, 6, 12. So start with the largest number and see which one goes into 30. Does 12 go into 30? No. Does 6 go into 30? Ding, ding, ding. So that's my greatest common factor for the number. So I just take the smallest number, write all of its factors, and then go backwards down the line and find the largest one that goes into both. I mean, you may have other tricks, but this is what my head does. Starts with 12, then it goes to 6. Now we have to compare variables. Remember, take the smallest exponent. So x to the 4th, y to the 3rd, and z squared, or z to the 2nd. So that's called my GCF. Now I'm factoring by dividing each term by 6x4, y3, z2, 6x4, y3, z2. So 30 divided by 6 is 5. X to the fourth divided by x to the fourth, that's going to be gone. Or not gone, but anything divided by itself is 1. I don't like gone. So 6 minus 3 is y cubed. And z squared divided by z squared is 1. So no x left in the problem, no z. They canceled each other out. And then minus 2. 7 minus 4 would be x to the third. 3 minus 3 means there are no y's left. So that'd be 1. And 4 minus 2 z squared. So let's do a quick manual check and just make sure we're good. So this gets multiplied by that. 30, 4 x's, 6 y's, 2 z's. 30, 4 x's, 6 y's, 2 z's. Boom. Minus 12, 7 x's. Yep. 3 y's. Yep. And 2 plus 2, 4 z's. There we go. So we can walk away and go, yes, I know I got that right. And then also be sure and glance and make sure nothing's common in there. No numbers common, no letters common. Otherwise, that means you missed something. Okay, so that's called factoring out a GCF. So the next thing we're going to learn is our 8 factoring patterns require that we don't have a negative in front. If you're ever asked to factor something and you have a negative in front, we do what's called factoring out a -1. They call it negative factor, but I call it -1. So you want to get rid of that negative in front so that you can factor what's left after it. So we call it a GCF of -1. And sometimes there might be more. Like here, I know I need to take a negative out because there's a negative in the leading term. So you never want your leading term negative. The minute you see it's negative, you should put that out front to take out as a GCF. Then you also have to search 3. Does 3 go in there? Yes. Does 3 go in there? Yes. Is there any letters common? Nope. So then you divide each of these by -3. And then I get positive 1x squared, which is just x squared, negative 4, negative 4x, and then negative divided by negative, positive 6. And see now how I now have a polynomial without that negative in front. So then that allows me to factor with ease. And we'll learn other ways to factor, but for right now, we're just worried about getting that negative out and anything else that might be common. So let's do one more, and then you can do one. So, is there a number common? 1, 9, 21, 18. Nope, because this one's 1, so I can't take a number out. Is there a y common? Nope. So if there's not a number common and not a y common, then you would just take out 1. But with a negative because the leading term's negative. So that leaves me with positive y cubed, negative 9y squared, negative 21y, and negative 18. So if there's no number common or no variable, we always have 1, but we're picking -1 so we can get rid of that negative in front. So go ahead and turn off the video and do that next one, and then we'll check it. So I see I need to take out a negative, a 5, and a u to the first. So negative 5u, negative 5u, negative 5u. So smallest exponent. So I get positive 3 u to the third positive 2u squared negative 5.